Good morning. Welcome to this seminar today. It's a real pleasure to have so many of you join us from all over the place. Actually, it seems as if we have a really strong gathering of folk from a variety of locations. I'm just going to take a few minutes to introduce you to the work of Digital Catapult itself. My name is Jeremy Silver. I'm the CEO of Digital Catapult. And the Catapult is an organisation that is funded by the UK government through Innovate UK. It is one of a network of catapults across the UK whose goal it is to accelerate innovation from the research base into commercialisation. And there are catapults in very specific sectors like cell and gene therapy and offshore renewable energy. And the digital catapult is probably one of the most horizontal by definition. And so we have to, in lots of ways, refine our focus in order to actually be effective. But we work with organizations, both large and small. We probably work with about 500 startups every year and early stage companies and scale ups, and around 100 corporates of one sort or another. And our programs are designed to bring those people together, mostly around facilities that we build and develop, where we can identify that the market itself has not yet got the appetite to invest. So ahead of the market, but in places where we see opportunity for UK businesses. And we work both in two main sectors. One is manufacturing, and the other is the creative industries. And although we also touch other sectors as well, those are the two main areas of focus, largely because they between them represent an incredible opportunity, an incredible digital dividend, if you will. And so we spend a lot of time talking to government and talking to startups and corporates and to investors and to academia in our attempts to identify real areas of opportunity. So we've spent time working with people in the telco sector, where we focus on digital infrastructure, and we have been leading the UK's innovation work around 5G over the last 3 or 4 years, building test beds in multiple locations around the UK of a very advanced kind, which are really capable of developing further innovation on top of 5G and now moving into what's called Open RAN, open source solutions. We work very closely in the immersive technology sector, where we see the use of augmented reality and virtual reality spreading remarkably beyond the world of entertainment into product design and innovation, into manufacturing and remote maintenance, and a remarkable spread of technologies which have not moved so fast into the entertainment space, but have moved very interestingly into industry. We see enormous potential still to come in that space. And finally, we work in areas such as artificial intelligence and distributed ledger technology, where we're very active looking at how to make supply chains more transparent, how to increase connectivity and data flows in supply chains, and using technologies like DLT to secure and memorialize information in those environments. So we are about 150 people based in London, but we have activities across the UK and very involved with trying to support the government's levelling up policy. We have a great deal of activity in Bristol. We have just begun a new initiative in Birmingham. We have 2 satellite centres, one in the northeast in Sunderland and one in Belfast. And our view of how to drive innovation is really all about trying to connect the energy and the inventiveness of UK startups and scale-up companies with traditional companies that are able to take advantage and increase the absorptive capacity of those kinds of businesses. So it's a real pleasure to welcome you all to this session today. I could talk a lot more about what we do, and if you want to know more, I'm sure that Brian will be able to tell you, and that and there's lots more information on our website, of course. In times of recession, businesses tend to respond in the negative. They tend to go to retrenchment. They tend to pull in their horns. But in a sense, from our perspective, the best way out of a recession is through innovation. and driving inventiveness and driving new opportunity, both in emerging sectors and in traditional sectors, seems to us to be the key and the way that we can help the UK recover from COVID and then move on beyond. And we've been busy helping companies in very hands-on ways during the COVID impact of COVID. We've moved very closely to companies, and virtually all of our programs are now online. So about 80 different programs running concurrently, with working with people like Siemens and Seagate, for example, in Northern Ireland, to develop the business case for their investment in 5G, for example. But there is an important element of our work that is still undeveloped, and that's really how best to evaluate its impact in the economy as a whole. We can find proxies in our immediate partnerships, and we can see the value to our immediate customers, but we really want to go beyond that and be confident that we're using public money as effectively as we can. And so this whole area of agent-based modeling that you and colleagues have all been so interested in and have been pushing forward so interestingly is of real importance to us and real relevance to us in a very direct, very hands-on kind of way. But we also see the incredible breadth of potential that it has. And so it's fantastic to see a whole session being organized around this today. And I hope that the outcome from this is that this kind of work and this kind of modeling becomes more and more accepted into the mainstream and is a really valid way of evaluating the kind of work that organizations like ours do. So the eternal optimist, we're extremely pleased to welcome Andy Haldane to give the opening keynote today to this series of panels that are going to explore agent-based modeling and the policy around them. I think it's fair to say that Andy's support for the wider adoption of agent-based modeling within economics has been an important contributor to the wider research within UK policymaking. His comparison of the failings of economic forecasters to the infamous Michael Fish moment in weather forecasting was a stark illustration of the need for new approaches. Andrew Haldane is the Chief Economist of the Bank of England. He's a member of the Bank's Monetary Policy Committee, Chair of the Government's Industrial Strategy Council. Among other positions, he's the Honorary Professor at University of Nottingham, a Visiting Fellow at Nuffield College, Oxford, a Fellow of the Academy of Social Sciences, and has authored over 200, I think I was going to say 2,000, Andy, but I'm not sure even you are that prolific. 200 articles, but 4 books. As the founder and trustee of Pro Bono Economics, a charity which brokers economics into charitable projects, a trustee of National Numeracy, and a patron of the charities Reach and Speakers for Schools. It's a real privilege to have you join us today. Please give a warm welcome online to Andy Haldane. Thanks very much. Andy.
Well, Jeremy, thank you very much for that very generous and kind introduction. It is indeed 200 rather than 2,000. And good morning, everyone. Apologies for the late start, which is entirely my fault. I'm delighted to be talking to you this morning about agent-based models, ABMs, and their application in public policy, organized by the digital Catapult. I've visited quite a number of the catapults over the past few years. They do fantastic work. And as Jeremy mentioned, never has their work been more important than just at the moment. I think the words he used were innovation as a route out of recession. And that is absolutely right as we seek to build back better. I think it's also absolutely terrific that the Catapult has pulled together this network drawn from across government, academia, some business and think tanks to develop thinking about using ABMs in a number of what are clearly crucial public policy areas. That's just the sort of collaboration I think we really need at the moment, but which often remains rather elusive. And I'm particularly looking forward to the panel sessions at today's seminar, covering economic growth and innovation, covering national infrastructure, covering the physical environment, and covering social and health policy. It goes without saying, although I'm going to say it anyway, that these areas of public policy could scarcely be more important than at present. as we deal with the triple challenges of COVID, of building back better, and of hitting net zero. I think in that environment, that difficult, that troubled environment, any modeling framework that can help us better understand the joint dynamics of our social, economic, and ecosystems, and indeed can help us in the setting of public policy to support those systems, is of potentially tremendous value. And from what I've seen over the years, both reading and a bit of writing, ABMs do have the potential to play that role, not as a substitute for, but very much as a complement to existing modeling approaches. I'm sure today's seminar will tell us much more about how that potential is best fulfilled. So let me expand in my short opening comments a little on that theme. Truth be told, even before the COVID crisis struck, there were a number of very good reasons to think that ABMs held promise. Indeed, I'd say rising promise when it came to understanding behavior and when it came to framing policy in a wide range of environments. Now, I think one reason for that promise came from ABMs having already been successfully applied in what is actually an astonishingly large number of other settings, spanning certainly the whole of the natural, physical, and social sciences, and going from the very micro, for example, models of the wiring of the brain, to the ultimate macro, models of the entire universe. I'd say that more recently, there appears to be three further sets of factors which have further increased, I think, the potential for ABMs to help support public policy. If you like, there's been an alignment of three further stars, and let me mention those in turn. The first is in the area of data, or more specifically in the area of big data, where, of course, as you all know, there's been an explosion over recent years in both the quantum and the granularity of data, some of it housed in government, administrative data, some of it sourced in geospatial data, some of it coming from household and business surveys of various types. Those new data are, I think, generally transforming how we monitor certain systems. That could be traffic systems, it could be ecosystems, it could indeed be economic and financial systems. For example, just on that front, most recently, many of us in public policy have been drawing very extensively on high frequency, highly granular data, so-called fast economic indicators, to try and make sense of how the economy is doing post-COVID. And those self-same data can be used, have been used, also to calibrate or to estimate high dimension models, including ABM type models. Those big data give ABM models both greater realism and indeed greater accuracy than ever previously, and that in turn increases their usefulness and crucially their robustness when it comes to using them in the setting of public policy. And as more data comes on stream, as inevitably it will, I think these data-related benefits would be expected to grow over time, including for the estimation and calibration of ABM models. The second star, I think, in increasing alignment has been the emergence of ever higher speed processing and computing power that enables us to simulate very large scale, high dimension models at incredible speed. Among other things, this allows greater replication. It allows greater degrees of dynamic updating of ABM models, and that too tends to improve their accuracy and their robustness over time when it comes to addressing public policy questions. And there again, as compute power continues to rise, we'd expect those benefits to grow over time further as well. The third dimension and the third star, I think, in increasing alignment concerns the connectivity and the complexity of the systems with which we are dealing. The systems we're discussing today are, I think, in every case, increasingly interconnected and complex, whether it's ecosystems or health systems or economic and financial systems. We can't really think of those anymore as distinct subsystems, whether nationally or internationally. As I think the COVID crisis illustrates only too clearly, these systems are very tightly and increasingly tightly coupled. And that means we're making sense of them, whether individually or collectively. It's only possible to do that if that coupling is taken seriously, and indeed, if that coupling is measured empirically. I think, indeed, it might be better to describe what we're discussing today, not so much as complex systems, as much as complex systems of systems. The economy, as we are seeing, is a system of interlinked sectoral subsystems, not least through our national and international supply chains. And the self-same is true, I think, of our national infrastructures, of our environment, and of our health and social care systems. And we know that the denser and the more complex these systems or systems of systems, as has been the case over recent years, the greater the value that comes from modeling these systems using frameworks that recognize not just the heterogeneous moving parts within them, but crucially the interactions between those moving parts, as of course ABMs do. Now, I think it's fair to say, as someone from the economics profession, that our profession, both in general terms and relative to other disciplines, has been, I think, relatively slow and sluggish when fully appreciating the benefits I've just mentioned, and when it comes to investing sufficiently in models of that type. And that's true, I think, despite the rising tide of connectivity and complexity that we've seen in many economic and financial systems over recent decades. Just think of the cat's cradle that is our international money and financial system. Just think of the cat's cradle that is our international trading system. Now, I think some of that ABM aversion, if I can call it that, reflects a degree of built-in inertia in the economics profession, which over recent years at least has tended to favor, at least at the macro level, rather aggregated, often representative agent modeling frameworks. The global financial crisis of 10 to 12 years ago, I think, exposed some telling fault lines in that highly aggregated approach to both modeling the economy and modeling the financial system. Back then, painful experience taught us that even simple sectoral interactions, such as, say, between the financial sector and the non-financial sector, had often been neglected, or indeed in some cases entirely overlooked, in our workhorse macroeconomic models. And it's no surprise, given that, I think, that this left many of them unable to come close to explaining the highly nonlinear knife-edge dynamics of the economy and financial system that we saw back at the time of the global financial crisis. I think a second, maybe a slightly worthier reason why take-up of ABMs among the economics profession has been slow is that many economists simply fail to appreciate just how ubiquitous or how useful those models had already been. Or perhaps we simply fail to understand what was feasible technologically with those approaches. I count myself in the second category, actually. Just as a personal example, a few years ago now, we hired into the Bank of England a plasma physicist who also was a specialist in ABMs. And when I met him during his first week at the bank, actually, I explained that we at the bank had been experimenting with some ABM approaches, but had found their high dimensionality a bit difficult to handle. Perhaps with as many as 6 or 7 interacting sectors or agents. Now, when he said he didn't think that was especially high dimension, I asked him what dimensional models he was used to simulating, and he said, well, typically around 10 to the 8. At which point I shut up and started taking notes. Now, the person in question, Arthur Turrell, has since gone to be a co-author of mine on a range of ABM papers. And I hope, like today, this is an example of just the sort of cross-disciplinary collaboration we really need to tackle the pressing policy problems we all face right now. Even pre-COVID, the Bank of England had been making some investment in ABM technology to help us understand the housing market, to help us understand financial markets, to help us understand the broader economy. And that had yielded quite a lot of promise and success, I think. And I hope in the light of COVID, we will be redoubling our efforts on that front. I want to end, before passing across to any questions that there are, on an optimistic note, actually, because I think unlike 10, 12 years ago at the time of the global financial crisis, during this time's COVID crisis, I have not seen the same degree of inertia, either among the academic community or indeed among the policy community. In fact, the contrary, I think both have exhibited a refreshing degree of flexibility in their response to this time's extreme events. Both have drawn on new data, on new approaches, on new models, and many new policies have also been put in place at what is being, at least by historical standards, warp speed. Just look at academia, where publication lags on papers have shrunk from years to months or even weeks in some case. This is one COVID-related change that I hope does stick. And when it comes to policy, during the COVID crisis, we at the bank have actually consciously stepped away from those standard, highly aggregated representative agent models when it comes to understanding the economy during the course of this year. We've relied instead on some rather more disaggregated sectoral approaches, because in this environment, we think that bottom-up approach helps us both in understanding the speed and source of economic fluctuations, but also when it comes to making sense and forecasting where the economy might go next, which is of course a pretty difficult and fraught exercise just at the moment. That disaggregated approach is also one that I hope sticks beyond the immediate crisis period. Academically, we've seen the emergence recently of models which fuse together insights from epidemiology on the one hand and from economics on the other, and crucially, the interaction between the economics and the health dimensions of policies. These so-called Epimacro models are also ones that we at the bank have been making some investment in over the past few months. There are also a rising tide, I think, of emerging examples of ABM approaches being used to explain the truly extraordinary undulations in the economy we've seen over the course of this year, including through the effects of supply chain interactions. All of that, I would say, all of that is very fertile soil for today's seminar, which seeks to apply the self-same technologies to some of the largest to some of the thorniest and to some of the most pressing public policy issues facing us today. So whether your ABM model has 10 to the 8 moving parts, or just the 6 or 7 like mine, I look forward to learning lots more from today's events about the approaches you've all been taking. And I hope, final point, for all our sakes, it can make a contribution to improving public policy, be that health policy, environmental policy, social or economic policy. It's never needed more than at these troubled, indeed troubling times. Jeremy, let me stop there and pass across and see if there are any questions people want to ask.
Andy, thanks so much. And that was excellent. And if we thought we were going to get 6 or 7 little gems from you, we now know we've got 10 to the 8th, which is excellent. And no doubt that will, I hope that will be true for the rest of the day as well. We haven't got very much time, but I think there was one question that came through, and you sort of hinted at some of this, but the sort of sense of inertia that you referred to in terms of people's willingness or unwillingness to adopt new models, and the sense of the urgency on the one hand of needing these sorts of models, and yet the sort of historic inertia that's built in, you know, from lack of precedent or lack of continuity that arises, not to mention, you know, doing something in one country that isn't done elsewhere. How do we sort of break through that in some way so that we could really start to introduce ABM more effectively, do you think? I mean, during the day, I'm sure we'll hear lots about the details of how to refine models and how to perfect them, but how do we really get them introduced as part of policy?
Well, I should say on that front, Jeremy, I wanted to sound an optimistic note at the end, that I think that there has been a bit of a breakthrough on that front during the course of this year. I think, you know, the global financial crisis was such a searing experience for so many people, whether it's in academia or in public policy, that I think in a way that has helped flex a muscle or two this time. Very helpfully so. I think the global financial crisis did spawn quite a bit more cross-disciplinary thinking than was happening previously. As today's seminar illustrates, I think extremely well, and that's been helpful. That too can help people break free of their inertia, and has over the past few months. I think public policymakers like myself do have an important catalytic role to play, and policy institutions like the Bank of England have an important catalytic role to play. If we ourselves start making use of these and other modeling approaches, I think that will cascade down both to other areas of policy, other government departments, and indeed to academia. If we suddenly start saying that, look, we take, 100 graduates a year, we need them to come equipped with this technology, because it's the technology that we ourselves are using, that can trickle down academically, and it can trickle down across the other arms of public policy too. So I think there's cause for optimism, but this needs a firm nudge. And I think public policy institutions, and there's many government departments, I think here at the seminar today, need to play a leadership role. And what better time to play a leadership role than now, frankly.
Excellent. Well, absolutely. I think the lead needs to be taken. And there is a kind of urgency, as you say, about that. We're rather short on time, so I'm going to ask you one more question, and then we have to move to the panel. But I hope you'll stick around for the panel and maybe be able to participate in that as well. But there's a question coming which I think is really interesting. And you know, when you think about some of the questions that have been arising recently, looking at the sort of challenges of unconscious bias, for example, in data collection, that people looking at artificial intelligence have become quite concerned about. One of the attendees is asking, how do we avoid the trap of simply collecting more and more data and not thinking about the mechanisms that actually generate that data?
No, it's a risk. It's a big risk. And I mean, I played up the benefits of big data because I believe they are very considerable, but there are perils too. and plainly, the sort of biases you mentioned would be one example of that. An exaggerated sense of history replicating itself would be another. Indeed, when the economics profession started moving away from large-scale models towards smaller-scale ones, that was kind of partly born out of fearfulness that those big models were not robust to changes in behavior or changes in policy over time. And that has a lot of legitimacy, I think. For me, one of the great merits of the ABM approach is that it does take that intrinsic uncertainty about the fortunes of whatever it might be, the economy or the environment. It puts those center stage. It puts those front and center. It gives rise to, naturally, the possibility of some high degree of intrinsic uncertainty as distinct from risk within those systems. It forces you to confront those head on. And for me, that robustness principle is absolutely key when it comes to not over-reading the runes on the use of big data. So for me, there's no inherent inconsistency between the greater use of data and a concern for model robustness. In the right hands and the right framework, those two things ought to be mutually supporting, not mutually contradictory.
Excellent. Well, there's a lot there, clearly, that still needs to get worked through, but really interesting. Excellent. Thank you so much. Wonderful to get your insights this morning. Sorry we didn't have more time to go into one-on-one questions, but I think we now are going to move across to the panel. So Andy Haldane, thank you so much. 10 to the 8th it is. And Brian, I'm going to hand over to you.